Everybody remember graphing quadratic equations? Y equals x squared. We talked about it in this class a little bit. Guys, get your note packets out. Now listen. All right. Quadratic equations, right? And this isn't going to. Standard form, y equals ax squared plus bx plus c is standard form of a quadratic equation. There is a vertex form of this equation as well. Do we remember? Do you remember the vertex form of an absolute value equation? Well, there's also a vertex form of the quadratic equation. And that is y equals a times parentheses. We're not using absolute value bars. We're using parentheses. X minus h. And because it's a quadratic, we have to have squared plus k. Looks pretty familiar, right? What does the h do? Just like our absolute value function. What does the h do? Moves or shifts. Which way? That's right, left or right. And it's opposite sign. What does the k do? Up, down, follows the sign. And what does the a do? That's right, flips. And either stretch or compress or narrower or wider. Okay, now, where's your packet? A changes from function to function, okay, as far as the wider or narrower. But the minus sign is always going to flip our functions. Everything else stays the same. The h shifts it left or right, depending opposite of the sign, and the k up or down follows the sign. All right, do you guys remember the parent function y equals x squared? I told my other class that I wasn't going to go over this because you spent months on this in Algebra 1, and I have talked about this in this class. What kind of shape do I have here? That's right, a parabola or a parabola. I like saying parabola because it sounds like it's fun to say. The virus sounds like a virus. Parabola. All right. If I were to do an XY chart or put this in a calculator, everybody remember this? My vertex is at what? That's right, 0, 0. Negative 1 comes out positive 1. Negative 2 comes out positive 4. 1 comes out 1, and positive 2 comes out 4. 0, 0 is our vertex, our HK, right? -1, +1, -2, +4, and the axis of symmetry in this case is x equals 0, and we get this parabola or U-shape, or as we mathematicians like to call it, parabola. And you guys spent months and months, and you did y-intercepts and factoring and all kinds of stuff, dealt with quadratics, right? Okay, well, this time we're going to look at square root function or radical function. And the parent function for that is y equals the square root of x. So let's make our t-chart x, y. Okay, what's the easiest number to pick? 0, 0. Well, we got to find out what it is, right? 0, plug in 0 for x, square root of 0 is, and it does happen to be 0. Okay, square root of 0 is 0. This is where your charts that you guys saved is going to come in handy, right? I want to pick perfect squares to make whole numbers for my y. What's the next perfect square higher than 0? 1. Square root of 1 is 1. What's the next perfect square higher than 1? Thank God you guys saved your charts. How about 4 and 2? You pick 4. The square root of 4 is 2. Okay? Now, how about -1? What's the square root of -1? Nope. 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 Why? Nothing, because that's what it says in the calculator. Close. Close. What's the square root of -1? Nope. Nope. Why? Because you cannot take the square root of a negative number. No, you can't. Very good, Patrick. Not possible. No solution. Okay, let's see if I can catch you. What's the square root of -4? Ah, very good. Okay, so our function starts at 0, 0. Okay, think of that as like your vertex point. That's your HK, 0, 0. Okay, now, okay, let's plot some points here. 1, 1, 1, 1, 4, 2, 1, 2, 3, 4, up 2. Give yourself at least 3 points here to make an accurate graph. There's my parent function, y equals the square root of x. Now, they give us a little example here. Okay? Let's look at this example. Y equals square root of x minus 2 minus 3. What's my transformations here? What's my transformations? What does it do? You just had a quiz on this. What does it do? Down 3. Wonderful. What else? What else? What is that? What is that -2? It's inside my mathematical symbol. This time it's the square root to the right 2. Wonderful. Okay, so I'm going to start with my HK, which is 0, 0. I'm going to go to the right 2, down 3. Okay, I'm going to go to the next point that I have. I'm going to go to the right 2 or down 3 and down 3. Next point, right 2, down 3. And there's my transformed graph. See how easy that is? Easy, easy. Because it's like the absolute value vertex form that we did. Inside our absolute value bars, it moved to left or right, the opposite sign. Well, we just happen to have the square root symbol instead of absolute value bars. So my H is opposite what's inside the math symbol. So I'm going right to. Because it's outside, that's my K. Excellent. Okay. While we're on that whole subject, let's name the transformation for the shifts in these. Okay, number 3. Which way is it going to go? Down 3, left 4. How about number 4? Up 1, left 2. Number 2? Good. And number 1? We did the parent function of square root of x. We could not get any negative numbers because we cannot take the square root of a negative number. Just copying it from the one we did up here. Okay. Now, let's talk a little bit about the cube root. You don't have to memorize this because you're always going to have a calculator. And in about 5 minutes, I'm going to show you how to do all of these in a calculator. Okay, let's do it without a calculator first. X, Y. Let's start with the easiest. What's the easiest? 0. Cube root of 0 is 0. Okay, what's the next perfect cube from 0? 1, 1. What's the next perfect cube from 1? Cube, perfect cube. Perfect cube. Perfect cube. Huh? 8 and 2, right. Perfect cube of 8, the cube root of 8 is 2. Who said that? I thought you did. That's, yeah, sorry. 2 times 2 times 2. Okay. Perfect cube. All right, what about -1? What about nope. What's -1 times -1 is +1 times -1 is -1. Okay, cube roots, you can have negative roots. So what's going to be the next perfect cube smaller than -1? -8, and what are you going to get? -2. Okay, let's plot these. see, 0, 0, that's going to be our HK, right? Let's see, 1, 1, 8, 2, negative 1, negative 1, negative 1, negative 1, negative 8, negative 2. Let's see how this goes. Oh, that's gorgeous. Hey, what's my domain for this? What are my x values? Negative infinity, positive infinity. What's going to be my range? These kind of go up and down, okay? So negative infinity, positive infinity. So domain and range for roots are going to be negative infinity, positive infinity. Always in this class. Now, it's a little different for square root, which could be my domain. What is my x? What's my least x value? And where's it going? What's the range? There you go. Wow, this is great. You guys have really got this. Huh? It kind of goes up. Okay. It's not that exaggerated, but let's talk a little bit about the A. Okay. If my A is negative, what happens? Nope. It doesn't forget. It flips. It's the same thing for this, for the square root and cube root function. If A is negative, it flips. What about if A is a fraction between 0 and 1? It what? It narrows or widens, yes. What does it do for the absolute value function? It widens it, right? Let's see what happens with the square root or cube root function. Let's take out our calculators. In fact, let's see. Let's go ahead and let's graph our parent function here. Okay, just to see what it looks like on a calculator. Well, I'm going to show you. Okay, everyone have a calculator? No, we're not doing absolute value function. We're doing square root function. So I'm going to have to hit the second key. See it? You can see it. Second key. And hey, stop that. I want it there. Okay, second key. And see the X squared button? I want to hit that because that brings up my radical, my square root. And then I'm going to put in the X, close the parenthesis, and graph it. Now, here's the X button. Okay, so instead of doing the chart manually, we could have done what? Yeah, we could have brought up the table on the calculator. Second, graph is our table. And there's my starting point. My HK is 0, 0. And my whole numbers, perfect square 1 gives me a 1. 2, 3 are not perfect squares. 4 gives me 4, 2. These are what we call the good points. When we make our graphs, we want to use the good points. Notice that we get an error when we try to take the square root of a negative number, because it's not possible. At least not yet. Okay, well, you're asking me, well, that's kind of cool. Let's try it for the cube root function, right? Oh, sure, Mr. D, that's pretty exciting. Let's do it. Okay, no problem. All right, y equals button. Now, if you want to keep that in your calculator and just to compare things, you could scroll over. You could scroll over to the left and just hit enter, and it will unhighlight your equal sign. But here's what we're going to, this is how we're going to put in the cube root. We're going to hit our math key. Then, see how it's down on number 4? Just hit the 4 key. And it brings up the cube root. Everybody got that? Because they're going to need it for the test, and you're going to need it soon. Okay, let's do it again. Okay, hit the math key and hit number 4, and it brings up the cube root. Got it, Lexi? Good. Kind of worried about you. All right, put in X, close the parenthesis, hit graph, and hey, lo and behold, there's my little squiggly line graph. Just put in X and close the parenthesis. Okay, now, do you know how I figured out all these numbers by hand? You could also get those from the chart by hitting second graph. Notice my good points here. 0, 0 is my kind of like my HK. It is my HK. 1, 1 is a good point, and 8, 2 is a good point. Then if you scroll down to -8, that's also a good point because you get a whole number. -8, -2. Okay? Now, let's go back to our A thing. We know that a negative number is going to flip it. Let's see what happens if we make our a fraction. Let's put in 1/2. Let's put in 1/2 cube root of x. So put your 1/2 in parentheses. 1/2 math 4 x, close parentheses. And we expect it to be wider because that's what happened in our absolute value functions, right? Let's see what happens when we hit graph. Wait, what happens? It got narrower, so it's opposite our absolute value function. Narrower, narrower. Yes, we can do it by hand. Okay, so it got narrower. It might be easier to think that in mathematical terminology here, narrower or compressed, right? It got compressed or squished. So what do you think is going to happen when my A is greater than 1? It's going to be wider, or stretch would be more appropriate. Let's go ahead and look at that. In fact, not only do we want to look to see if it stretches, let's see. Let's make it flip 2 at the same time. Okay, so let's put a -3 cube root of x in there. And let's see what all this does. The graph, and it actually pulls it apart, makes it wider or stretches. And see how that negative sign flipped our graph? Do you? Do you see it? Do you see it? See how it flipped it? It actually reflected it over the x-axis. Flipped it. Pretty cool, huh? You guys are so shocked. I just turned the top one off. I did that by highlighting the equal sign and stuff. You want to keep your equations in there? You could just turn them off by highlighting the equal sign or turning them off. Shall we do one of your practice homework problems? Sure, Mr. D, let's do one of them. Okay, flip it over. Let's do number 6. Okay, sounds like fun. What are my transformations here? Just, you don't have to write this down. Well, it depends on how the question. What are my transformations? Left 1 and up 3, right? Up. Okay, what else? What's 2 going to do? The A. Widen it. Wider or stretch, right? Okay. Now, you could make a t-chart and choose X and figure out every Y. What's going to be easier? That's right. See, you guys are learning. That's what you're supposed to do in this institution. Okay, I'm going to put in 2. Math 4 brings up the cube root. X plus 1. Have to close the parenthesis. Then I'm going to add 3 to the outside of our mathematical symbol. With me? You with me? Wait for it. Graph it. Okay, so it shifted it to the left 1 up 3 and it made it a little wider. Okay. So we have to accurately graph this in our paper. Let's pick some good points. Okay. I'm going to go to my table. Let's see. Here's my real 3 close points, right? So my HK is going to be -1, -1, 3. Because there's 3 points, it's the middle point. Okay. Plus, you can get it off of here. My H is -1, my K is 3. Okay. Let's see, the one after it, a good point, 0, 5. I could make a chart. Let's see, I need another one. Scroll. Oh, there's one, 7, 7. All right, let's go get the outlier one for the other side. Let's see, -9, -1. Okay, let's plot these. -9, -1, -1, 3, 0, 5, 7, 7. Does that look like my graph? Yes, it does. What's my domain and range for cube root functions? And -infinity, -infinity, positive infinity. Easy peasy, right? Guys have 5 problems to do tonight before I give you the bookwork tomorrow. And you. Any questions? Anybody need any Bengay or Icy Hot for their fingers working video games?